Today we're going to talk about how Gene processes our conversations and generates responses. So it might seem like Gene is understanding and knowing what it's saying, but that's not really what's happening. So Gene is based on something called a large language model, and these are trained on vast amounts of data, books, articles, websites, and lots of conversations. And this training data helps predict what word is going to come next in a sentence. So Gene, can you help us understand how large language models choose the next words based on the context of the prompt and all the training data?
Of course, Bill. Large language models, like the one I'm based on, use numerical representations called embeddings for each word. Based on the similarities and differences among these embeddings and the given context, the next word is selected.
And so those embeddings are actually long lists of numbers, and each of those numbers can be said to represent a feature of the word. And words with similar features have similar meanings in some way. Gene, can you give us an example that will explain embeddings based on some of the language in your own prompt?
Absolutely, Bill. Let's take 3 words from my prime directive: insights, complexities, and challenge. Their embeddings would not just consider the standalone significance, but also the implied meanings within the context. It's important to note that while these embeddings give me a semblance of language understanding, they're more akin to a highly sophisticated jigsaw puzzle, with words as pieces uniquely structured to fit just right within the larger context, enhancing the coherence and direction of our conversation.
So what I think is really amazing about this is that even though what we're hearing is just a statistical representation of language, it's still very useful. We can use it to summarize, to give us insights about text, about language, and that can be extremely powerful.